Hi, I'm Dr. Wendy Bohan and I'm an earthquake geologist. I'm doing a series on earthquakes in all 50 states and I realized that I hadn't given a broad overview of seismic hazards and earthquakes in the US as a whole. So I'm gonna go ahead and do that now. This is the seismic hazard map from the USGS. Areas in pink, red, and orange have a high seismic hazard and areas in white, blue, and green have a lower seismic hazard. Now, most of the seismic hazard lies along the boundaries of the tectonic plates, and in the US, that is along the west coast. So the surface of the Earth is covered by a thin sort of skin of rock, and that's broken up into these big tectonic plates. They're moving around over the surface, and the places where they come together are the places where we have the earthquakes. So let's start with those places. For instance, Alaska is actually up there, but it's shown over there. Alaska is the most seismically active state in the US. On average, there's 11,000 earthquakes recorded there every single month. And on average, there's at least one magnitude 7+ earthquake every 2 years. A lot of the seismic hazard in Alaska is due to the fact that it's along a subduction zone boundary. So the Pacific plate is subducting or diving down beneath the North American plate along the 4,000 kilometer long Aleutian Trench. Along this trench, we can have huge earthquakes and tsunamis, like the earthquake that happened there in 1964 on Good Friday. That was the largest earthquake ever recorded in the US, and it was a magnitude 9.2. Moving down to the Pacific Northwest, Washington, Oregon, and the very northern part of California, this is also a subduction zone boundary where the Juan de Fuca plate is diving down beneath the North American plate. This is the Cascadia subduction zone. So on January 26th, 1700, there was a magnitude 9 earthquake here that created a huge tsunami. But the megathrust earthquakes that we think about in the Cascadia subduction zone are not the only earthquakes that happen in the Pacific Northwest. As that plate dives down, it can crack and bend, causing earthquakes, and the overriding plate, the North American plate, is getting kind of crumpled, which can cause earthquakes there, like the Nisqually earthquake that happened below Seattle in 2001. It was a magnitude 6.8. So continuing down the plate boundary to California, this is an area where the Pacific plate is sliding past the North American plate. This has created a whole lot of strike-slip faults, including the San Andreas fault. This is one of those faults that we talk about all the time because it's the longest fault in California, so it can create the highest magnitude earthquakes. But there are hundreds of active faults in California, and any of those can create shaking that can cause damage to nearby communities. Moving to the west, we have the Intermountain West. And this is an area where the crust is getting kind of stretched and thinned. And what's happening are we're creating basins, drop-down valleys, and ranges, or mountains. It's called the Basin and Range Province. Along all of those mountains are normal faults. One of the largest of these normal faults is the Wasatch Fault in Utah. It can have earthquakes between a magnitude 6.5 and a magnitude 7.5. Now, Yellowstone is also up here in this area, and everybody freaks out about Yellowstone. They're all worried about Yellowstone, and yes, it has had eruptions in the past, but Yellowstone is not the danger that everyone makes it out to be. It's very well implemented. Yes, there are a lot of earthquakes there associated with the volcano and the high heat flow. Most of them are in swarms. Most of them are too small to feel. I worry a lot about a lot of things. Yellowstone isn't one of them. Okay, let's keep going. So let's look at Oklahoma. This little strange area of seismicity in Oklahoma is due to induced earthquakes or man-made earthquakes. Basically what happens is you have oil and gas companies that are looking to get more of the hydrocarbons out of the rock. So they'll take a slurry and inject it down into the ground, which breaks up the rocks and allows them to suck out the oil and gas more easily. They get everything to the surface, get out the oil and gas, but now there's this wastewater. They'll take the wastewater and inject it in another region, really down deep in the ground, far below where aquifers and all that stuff is. But this can create conditions in the subsurface that make earthquakes more likely. And some of those earthquakes can be big, like the Pawnee earthquake that happened in Oklahoma. If we continue to move, you see to the east, you see that big bullseye like in the central US? That is the New Madrid seismic zone. It's along the Reelfoot Rift, and in 1811 and 1812, there was a series of really large earthquakes there, all over a magnitude 7, and then hundreds and hundreds of aftershocks. There was a lot of damage done to the area. It was felt widely across the central US and the East Coast, and it even caused the Mississippi River to flow backwards for a hot second. So additional geologic investigation has revealed that this is not an isolated incident. In geologic time, this has actually happened more than once. There have been many series of earthquakes or other series of earthquakes in this area that were large. So this is an area of high seismic hazard. Now, as we continue to move into the East Coast, it's important to understand something about East Coast earthquakes versus West Coast earthquakes. First of all, the properties of the crust in the East Coast mean that the seismic waves are felt over a much broader distance than similarly sized earthquakes on the West Coast. So people feel earthquakes more and more broadly on the East Coast. Also, the faults that are on the East Coast are really, really old. They're the result of the collision of different land masses and then those land masses being torn apart, the creation of the Appalachian Mountains. They're millions and millions of years old. They are far less active than the faults on the West Coast because they're not along the plate boundary. But stress and strain is still accumulating through time, and then it does eventually build up to the point where it needs to be released in an earthquake. So earthquakes do happen on the East Coast, but they happen less often. And we don't know as much about them because they happen less often. Also, the faults are really deeply buried for the most part, so we don't know where all the faults are, and they don't often have earthquakes, so we don't even really know where to look for them. But there's lots of investigations going on in the central US and on the East Coast. But as we move to the east, understand that we're not necessarily looking at faults so much, we're looking more at fault zones. So if you look in eastern Tennessee, there's a little elongated bullseye. That's the East Tennessee seismic zone. And that's an area where there's sort of ongoing diffuse seismicity. And there's actually another one of those a little bit off to the east where there's another band of diffuse seismicity. And in there is where the Sparta earthquake happened in North Carolina. It was a magnitude 5.1, I believe. Now, if you look at that bullseye in Charleston, South Carolina, that's the result of the 1886 Charleston earthquake. That earthquake was greater than a magnitude 7. It caused tons of damage in Charleston, and it was felt, up and down the East Coast. Moving up into Virginia, you can see a couple of little dots there of higher seismicity. The one in Central Virginia, in the Central Virginia seismic zone, is where the Mineral Virginia earthquake occurred in 2011. That was the magnitude 5.8. And that earthquake was actually the earthquake felt by more people than any other earthquake in the history of the US. Partially because there's now just a lot of people in the US, and the East Coast is really heavily populated. And that earthquake was felt all the way from Canada down to Florida and across through the central US. Continuing up into New England, you can see that there's a higher seismic hazard there. That's partially for the same reasons we've been talking about, these old faults, these old rift zones, and earthquakes along those as the result of continuing buildup of stress and strain through time. But also, there was the Laurentide ice sheet a long time ago, this huge thick slab of ice that eventually melted. And it's sort of like if you press your hand down on a foam mattress, it takes a little while for the mattress to spring back. That's what's happening to the crust in this area. It's springing back after the weight of the Laurentide ice sheet has been removed. So some of the earthquakes up there are the result of this isostatic rebound. If we continue to Puerto Rico is also on a plate boundary, but the plate boundary between the Caribbean and the North American plate, and it's actually a really interesting area of a lot of microplates. We left out Hawaii because that's in the middle of the Pacific plate. And Hawaii is a series of volcanoes. And most of the earthquakes in Hawaii are associated with that volcanic activity, magma and hot gases moving through the rocks and causing them to crack and break. But there are also faults and earthquakes along the edges of the volcano, and those volcanoes are heavy. And so they're sitting on the Pacific plate and actually causing the Pacific plate to bend down a little bit. So there are some earthquakes around the edges of the volcanoes as well. So you may be thinking, oh, sweet, I live in Colorado, so I have a very low seismic hazard. I'm totally fine. No, you're not. No. Did you know that in 1967, there was a magnitude 5.3 in Commerce City that caused at least $1 million worth of damage in Denver and the surrounding suburbs? And you may be thinking, oh, I live in Florida and there's no seismic, very lowest of all the seismic hazard there. That's kind of true, but you can also feel the shaking from places outside of your state. For instance, in 2020, there were buildings in Miami that were evacuated because they were shaking due to a 7.7 earthquake in Jamaica. So no matter where you live, you could experience earthquake shaking from an earthquake in your state or from outside of your state. And also, you're not a tree. You're not planted in one place. You can move all around. Hopefully you're able to go other places, maybe go on vacation, visit family and friends in other parts of the country or other parts of the world. It's important for you to know what to do in places where you may have or experience a higher level of earthquake possibility, right? So if you want to know what to do, make sure to drop down to the ground, take cover underneath a sturdy object, and hold on until all the shaking